Hi students, good morning all of you. Today's session we shall discuss about general organic chemistry 1 reaction mechanism గురించి ఈ వీడియోలో తెలుసుకుందాం. సో డైలీ ఈ చాప్టర్ కి సంబంధించి డైలీ 1 వీడియో అప్లోడ్ చేస్తాను ఎర్లీ మార్నింగ్. సో రియాక్షన్ మెకానిజం 1. సో జనరల్ గా రియాక్షన్ మెకానిజం లో అంటే ఎనీ కెమికల్ రియాక్షన్ జరగాలి అంటే ఫస్ట్ రియాక్టెంట్స్ అనేవి ప్రొడక్ట్స్ గా కన్వర్ట్ అవుతాయి త్రూ అన్ ఇంటర్మీడియట్. ఇన్ జనరల్ ఇన్ ఎనీ కెమికల్ రియాక్షన్ reactants will be converted to products. Reactants will be converted to products through an intermediate. Products. So this is the general idea. So the reactants anevi products ga convert avutayi always. So there is intermediate step before it is converting into product. So reaction lo general ga em avutayi first reactants molecules lo unnatvanti bonds anevi break avutayi. Bonds ante old bonds anni break ayipoyi new bonds anevi form avutayi. So ee bond breaking anedi two types ga untundi. Bond breaking is two types. One is homolysis and other is heterolysis. Bond breaking is two types, homolysis, heterolysis. So in homolysis, homo ante same ante bonds అనేవి ఈక్వల్ గా బ్రేక్ అయినప్పుడు అంటే వన్ బాండ్ కంటైన్ 2 ఎలక్ట్రాన్స్. సో ఆ 2 ఎలక్ట్రాన్స్ అనేవి ఈక్వల్ గా షిఫ్ట్ అయినప్పుడు మైగ్రేట్ అయినప్పుడు ఈక్వల్ గా బ్రేక్ అయినప్పుడు దాన్ని హోమోలైసిస్ అంటారు. హోమోలైసిస్. సో ఇన్ జనరల్ ఇన్ హోమోలైసిస్ కార్బన్ ఫ్రీ రాడికల్స్ ఆర్ ఫార్మ్డ్. Carbon free radicals. In homolysis, carbon free radicals are formed. In heterolysis, generally carbocations or carbanions or carboanions. Carbanions or carboanions are formed. And in carbene and nitrines also formed. In heterolysis, carbocations, carbanions, carbenes and nitrines are formed. In homolysis, carbon free radicals are formed because it is homolysis, so electrons will be shifted equally. So one bond contains 2 electrons, so these 2 electrons, one electron will be shifted to one species and other electron will be shifted to other atom. So that is equal breaking, homolysis. In heterolysis, so any one of the that electron pair will be shifted to any one of the 2 atoms in a molecule in a reagent. So that is called bond breaking. So ee cleavage anedi dani covalent అని అంటాం. అదే విధంగా covalent cleavage or homolysis ionic non ionic cleavage. Homolysis it is non ionic cleavage. And heterolysis it is ionic cleavage. So what is homolysis or non-ion cleavage? We shall discuss about homolysis. Homolysis or non-ionic. Non-ionic cleavage. Sometimes it is also known as covalent cleavage. So covalent cleavage means covalent bond will be cleaving in 2 types, homolysis and heterolysis. So it is a homolysis non-ionic cleavage. Suppose there is a molecule AB with a covalent bond. So in homolysis in homolysis. So this a pair of bonding electrons will be migrated equally. So in such a case, free radicals are formed. A radical and B radicals are formed. So these are called free radicals. So two electrons will be shifted equally, one electron to A and other electron to B. This is called homolysis. So usually this homolysis will be taken in the presence of non-polar solvents. Homolysis will be taken place in the presence of non-polar solvents like carbon tetrachloride CCl4 or benzene, carbon tetrachloride or benzene, or carbon disulfide, etc. Okay, in these solvents usually homolysis will be taken place, and also in some cases it is taking in the presence of sunlight. Okay, it will be represented with H nu. So in the presence of sunlight also homolysis will be taken place and free radicals are formed. And also at high temperature, when there is a high temperature, then in such a case also free radical mechanism will be taken place in the presence of high temperature and vapor in vapor phase reactions. In vapor phase reactions, usually homolysis process will be taken place, and also in the presence of peroxides. Usually in the presence of peroxides, homolysis, it means H2O2. In the presence of peroxides also homolysis will be taken place, and also when attacking reagent is a free radical. When attacking reagent is a free radical mechanism or homolysis takes place. These are the conditions to occur homolysis in the presence of non-polar solvents and in the presence of sunlight and at high temperature in vapor phase reactions and peroxides. In when there is a free radical, then free radical mechanism will be taken place. Okay, these are the main important points regarding homolysis. So next we shall move further to heterolysis. Heterolysis. So heterolysis means it is ionic cleavage. Ionic cleavage it is. So usually in ionic cleavage or in heterolysis, so this bond will be cleaving like this. Okay, in heterolysis. So as a result here, they will be breaking like this. So here A will be getting positive charge and B will be getting negative charge. Clear? It is heterolysis. In heterolysis, this bond is not breaking equally. It will be shifted to any one of the two atoms. Usually that will be shifted to the negatively charged particle or more electronegative atom in a molecule. Electropositive atom will be getting partial positive charge and electronegative atom will be getting partial negative charge. So that is cation and anion. That is why it is called ionic cleavage. So this heterolysis will be taken place in the presence of polar solvents. Polar solvents like H2O are in the presence of alcohols. Polar solvents. Heterolysis will be taken place in the presence of polar solvents and at low temperature conditions. At low temperature condition also this heterolysis process mechanism will be taken place, and when attacking reagent is ion, heterolysis will be taken place. Next, when in the presence of acid or base also heterolysis mechanism will be done. Okay, so that molecular species will be breaking unequally. Samananga break also. Any one of the, as a result, any one of the two atoms will be getting negative charge and other will be getting positive charge. So those are cation and anions. Discuss about what is carbon free radical. Carbon free radical. So discuss some important points about what is free radical. So usually when this bond is equally sharing, equally cleaving, so that is called homolysis. So in such case, radicals are formed. So in this one, carbon will be getting one electron and Z will be getting one electron equally. This is called homolysis. So here, what is carbon free radical structure usually? There are 3 bonds around the carbon atom and one electron. One single electron is present on carbon. So one orbital, so this orbital is now vacant because there are carbon valencies are 4 tetravalence. There are 3 bond pairs are present around carbon. So only one electron is present. So one more electron is required to complete its orbitals. So in this case, carbon free radical is sp2 hybridized because there are 3 bond pairs only. 3 bond pairs. It means it is sp2 hybridized carbon atom. Okay, and it is the shape of this carbon free radical is trigonal planar. Its shape is trigonal planar. Trigonal planar, and it has an incomplete octet. Incomplete octet. Okay, because around carbon there are no octet electrons complete. Okay, so it means it bond pair means 2 electrons. Okay, 2 electrons, then it contains 2 electrons. This bond pair total 4 electrons and 4 electrons and these 2 electrons, total 6 electrons, and there is one more electron, 7 electrons total. So incomplete octet it has. So carbon free radical usually it has an incomplete octet, and also it is highly unstable. Highly unstable it is, and also next it is more reactive. Unstable means more reactive. More reactive, and also behave as an electrophile because it attracting towards electrons because its orbital is vacant. One electron is less, so it is behaves like an electrophile. So carbon free radical is an electrophile, behaving like an electrophile. So these are the important some points about carbon radical, carbon free radical. So its structure is trigonal planar, and sp2 hybridization it is. Then incomplete octet it has, an highly unstable, more reactive, and it behaves like an electrophile. This is just some important points about carbon free radical. Next, carbocation. Carbocation. So carbocation, when it will be formed, carbocation generally in heterolysis only carbon carbocation and carboanions are formed in heterolysis. So when this bond is breaking unequally, so it will be shifted to any one of the 2 atoms. So mostly, so this Z will be, in case if Z is more electronegative, so it means electronegative of carbon is less than electronegativity of Z. Okay, then this bond pair will be shifted to Z. In this case, Z will be getting negative charge and carbon will be getting positive charge, plus Z minus. Okay, this is carbocation. This is called carbocation. Carbocation it is called. So in this case, Then what is the structure and what is the some important points about this carbocation? What are so what generally its the structure will be let's search. It is also sp2 hybridized carbon because 3 bond pairs are present. 3 bond pairs, sp2 hybridization, and also structure will be trigonal planar. Trigonal planar. And octet. What about octet? Incomplete octet. So ikkada complete octet anedi ledu. Incomplete octet. 8 electrons levu. Incomplete octet. So total 1, 2, 3, 4, 5, 6 only. Only 6 electrons are present. So incomplete octet. Then next, highly unstable. Highly unstable it is. And also unstable means more reactive it is. More reactive and behave as an electrophile. Carbocation also behaves like because electron seeking center, electron seeking particle. So it required electron to complete its octet. So that is why it is working as an electrophile. So next we shall discuss about carbanion or carbanion. Carbanion in heterolysis. This is called ionic cleavage. So in this case, if electronegativity of carbon is more than electronegativity of Z, then this bond pair will be shifted to carbon. So in such case, carbon will be getting negative charge, then Z will be getting positive charge. So this is called carbanion, negatively charged carbon, carbanion. Or carboanion also we can call. So in this case, what is the structure of this carboanion or carbanion? Because there is a lone pair, extra pair, okay, non-bonding pair of electrons are present on carbon atom. So now these bond pairs, so there is a repulsions between, there are some repulsions between lone pair and bond pair. So they will be moving away from each other to minimize these repulsions. So when there is a minimum repulsions, then that will be will be getting a particular shape. The lone pair and bond pair repulsions are present. So that is why so the structure of the this one species will be changing. So what is hybridization here? Hybridization of carboanion or carbanion. Hybridization is sp3 hybridization here. In this one, sp3 hybridization because 1, 2, 3 and one lone pair is present. So total 4 sp3 hybridization is present. Then what is the structure? It is very, very important. Carboanion or carbanion structure is pyramidal structure. Pyramidal structure. And the next one, complete octet. What about octet? Here 1, 2, 3, 4, 5, 6 and 7, 8. So it has complete octet electronic configuration. 8 electrons are present around carbon atom. So carbon, that is why it has complete octet. So complete octet and highly unstable, more reactive, behave as nucleophile because now it will be attacking at electron less centers, electron deficient centers. ikkadaithe electrons takkuva ga untayo akkada idi attack chestundi vaatni. Okay, సో ఇది దేనిలాగా పనిచేస్తుంది, కార్బో ఆనయాన్ న్యూక్లియోఫైల్ లాగా బిహేవ్ చేస్తుంది. సో మోర్ రియాక్టివ్, హైలీ అన్స్టేబుల్, కంప్లీట్ ఆక్టేట్ అండ్ పిరమిడల్ స్ట్రక్చర్, hybridization is sp3. So okay, these are all very very important points you can expect